Hello all, welcome to TechGig webinar. The topic for today's webinar session is DLR integration in WPF or Silverlight, a next generation capital markets application. We are delighted to have Mr. Manish Agrawal, Senior Specialist at Shaping Global Markets, as our guest speaker today. Mr. Manish has over 13 years of experience successfully leading large teams to design and implement complex business critical software solutions in the finance, insurance, automotive, and healthcare industries. Gentlemen, the session will continue for 45 minutes and you can ask your questions by typing in the chat pane available. So without further ado, I request Mr. Manish to continue.
I have just shared my screen as well.
Also, we can listen to you.
Okay, excellent.
Thank you.
So, welcome to the session. I will just bring up my presentation. Here it goes. I don't have a lot of slides here. Most of it will be code walkthroughs. Here's the agenda. We will look at what is a DLR. So the topic is how do we use the power of DLR, a dynamic language runtime, which is a new feature in .NET, to enhance the experience that users get when using a rich UI application developed using either WPF or Silverlight. Case in point is a next generation capital markets application. And we will look at a complex capital market application and how we can use a dynamic language runtime to further enhance the user experience there. So the agenda here is to look at what DLR actually is, to look at a hello world kind of an application to understand how we really integrate the dynamic language runtime into a regular C# program, for example. And what are the nuts and bolts? How do we start using it? Then we look at a typical capital markets application, rich UI based capital markets application. The people who are attending this and have experience with capital markets or financial applications will be able to relate to it immediately. But for other people as well, it is just an example. This could be relevant to any other application which has those kind of rich UI features. Then we will look at how we integrate the dynamic language runtime to provide a macro language or a domain-specific language within that capital markets application. And that is what brings out the power of DLR. I will take questions at the end towards, I'll take most questions at the end. You can keep typing them in anyway, and if something is like very contextual and I think it can go with the flow of the presentation, I'll pick them right there. Otherwise, mostly I'll just answer them towards the end. Okay, so starting off. So what is DLR? So dynamic languages like Python and Ruby have been around for a very long time. Dynamic languages like Lisp have been around for even before then object-oriented programs came along. The concept of a dynamic language is best brought out by looking at some of the features that a dynamic language provides. The first being a dynamic type system, for example. So let's look at what is meant by. What I just opened is the Python interactive editor. I can type in Python commands in there and they will be executed for me right there. So if I type x equals 24 here, and then I say print X, well, no rocket science, it type back 24. But the important thing here is that X is an integer. It is a type safe integer, and the language was able to interpret that based on the value that I assigned to X. So it is type safe. It is not like a the VB6 variant, if you remember. It is not like that. Similarly, if to the same variable X, if I let me just first create a definition of a class. So let's say class person, which has one function, def. So what I created here is a definition of a class. The class is, the name of the class is person. It has one function which is say hello, and it does what it does is it takes the self parameter, which is the same as this in C#, if you're familiar with that. And all I say is print hello self.firstName. What you would notice here, however, is that I have not declared this first name member variable on the person class. I am directly using this first name variable, but I have not declared it anywhere. So let's see what happens when I call this function. So to that same variable X, I assign a person object, and I say X dot I get an error. It says person instance has no attribute called first name. Fair enough, we never created it. But the beauty of a dynamic language is that I don't have to go back and edit my class definition. A variable gets declared as soon as I assign to it. So I assigned x.firstName, and now I call that method again. And this time we did not get an error. It was able to find out the value of that firstName variable, and it was assigned a string type. So it was all along, this is type safe, and this is a dynamic type in which I can add new member variables based on when I need them and so on. So the dynamic type system is one of the features. Similarly, you can add dynamic methods, which is called dynamic method dispatch. So the session is more around DLR, so I will not go into a lot of depth around Python and features, but I want to bring out this fact that there are dynamic types within and dynamic methods that you can have within Python. Coming back to our presentation, the other service that DLR provides in .NET is that it provides us a hosting API, which allows me to use Python features or Python scripts within a C# program. So we will look at that hosting API and how it is used and so on. So let's actually look at all of these features as they're being used from within a C# application, a hello world kind of an application. Here we go. So let's go to the top of this file. So this is a simple console application with a single main function. Just types in, just prints the first name. It has a single class called person, which has two properties, first name and last name. Not a lot of rocket science there. What I need you to notice is the references within this project. There's a reference to IronPython. IronPython is the DLR implementation of Python. And the other important thing to notice is the Microsoft.scripting reference. This is the hosting API which will allow me to host IronPython code within my application. So the important thing is that you can write entire programs, complete end-to-end programs within IronPython itself. You don't need a C# program like the way we are using here to be able to write code in IronPython. What we are trying to look at here, however, is how we integrate IronPython into a C# program, which is why we essentially have a console application using C#, created using C#, and it is hosting some IronPython code. Let's look at the main. So if you look at these using statements, there are two using statements here, Microsoft.scripting.hosting and IronPython.hosting. Both of these are used for incorporating the IronPython code. What we do here at the very first line of the main method is create a script engine, which is a Python engine. We also get Ruby.engine, similar to Python.engine we have here. And I don't know, there may be other implementations of other dynamic languages as well. So we first create a script engine, then we create a scope. Scope, as the name suggests, is just scope. It holds the, it is you can think of it as a container which will host the variables, and those variables will be available within that scope, and you can have nested scopes and so on. Again, that is a topic for another discussion in terms of how we should be using scripting scopes and so on. But the next thing you do is to create a scope. You need a scope to be able to declare any Python variables and so on. The next line is very interesting and probably the most important here, where I create the definition. You see here, what you see here is a string variable called definition, and to that variable I am assigning the definition of a Python function. So it's still a string. I am assigning the code that I had earlier written in that Python interactive shell. I have written the same code here, the same say hello function. This time it's just a function. It is not a part of a class, so it is not taking self. It is just taking x. It is it calls the x dot first name. But the important thing to note here is that it is a string. Then I call this create source from string. So what this is doing is that converting this string variable definition into executable code. And then I give this executable code to the scope. At this point, this is executable code that I can use somewhere else in my application. So what I do is I create a person object, person P. I assign the first name variable there. And then what I do is I create an action delegate, which is and I get the method that I had declared within that scope using that string type variable as an action delegate out of the scope. And finally, I call that action delegate. So if I run this program, very predictably, it prints out hello Manish. So again, the program is in itself is not doing a lot, but the important things to note here is that we that we hosted IronPython as a scripting engine. Then we created a scope, and we used some string variable, some dynamic data which was of type string. We converted that into executable code at runtime, and then we were able to call that executable code from within our application. So keep these 3-4 things in mind, and we will see how all these things come together when we talk of a rich UI application and the power this is able to add within that UI application, the rich UI application. So I'll close this and go back to my presentation here. So let's talk briefly about what is, what a typical capital markets application is, and what are some of the features, key features of such an application. A typical capital markets application deals with a large amount of data, and the users looking at that data are not just interested in the data, they are interested in doing analysis on that data. If you talk about stockbrokers or analysts or bankers, investment bankers, what they're looking at, what they get is a very large amount of data from stock exchanges, from their customers and so on, from news feeds, and they're basically trying to collate all of that data into information by doing analysis of various kinds. So they typically want to look at that data in different ways. So they want to look at the data as a grid. They may want to look at it as a chart, as graphs of various kinds, and they want to do analysis, like apply formulas, do computations. In the capital markets world, that is the reason why Microsoft Excel or any other spreadsheet application is a very key component of their day-to-day life. These financial wizards are masters of using Excel. They would slice and dice their data in so many ways using Excel. However, Excel is not their primary application, line of business application, in the sense that they may have a trading application, and what they would then do is within that trading application they would have some kind of an export to Excel functionality, and they will copy all that data there and do the analysis there, then come back to the trading application and take some action. So their Excel data is always like a snapshot of the real-time data, which is the market data, stock exchange data. So let's actually, instead of me talking about it, let's quickly look at an example of a typical capital markets application. I've created a demo app, which is a simplified version of a real order management system. For example, an order management system is something that a stockbroker or a stock trader uses to get orders from the client and then place those orders within the market, and to continuously look at the stock prices within the market and look at analysis of how much stocks have traded, what are the prices, and what are the trends, and so on. So this is a Silverlight application that is coming up. Is it on? Okay. So we have a grid here, and in the grid you see the various orders. There are different kinds of data that the user is looking at in terms of stock prices. This is being fed from a real price ticker, a real market, from real market data where stock prices are being refreshed in real time. Of course, I mean, I'm not using today's prices. I just have a feed that I batched and I put it at the back end. But the idea is that this is real-time data, and this grid is being updated at real time. The user can also look at charts. There are different kinds of charts here. There's a candles chart. There's a price to time kind of a chart. Time series chart, so to say. So they want to look at all of this data in different ways. Now let us look at I'm sorry. So that is what the screen of a typical capital markets app will look like as of today. Now if we were to give this user who's looking at all this data the ability to do ad hoc computations, whatever they want to do. For example, in the grid, if they want to add a new column, okay, so they add a new column here which says order executed quantity, and it is being computed using a formula. Now what you would see here is that we give the user the ability to create this new field within the grid which is order quantity. So what we're doing here is we have we're basically computing how much what is the value of my executions that I have traded so far. So I do order.executed quantity, which is the quantity that has already been traded, with the last price of that symbol. And the interesting parts to note here were that we gave him like an IntelliSense kind of feature where the user types in order and says start, and they get a drop down from which they're able to select like the existing attributes of the order class that we had in the background. Okay, so we have the data here. Okay, so we see that new column got added here, and we have data being updated on the fly again. So this was a purely ad hoc computation. The user created a brand new field on the order object, the order class that we had in our C# code. He created a new variable within that order object and provided the formula to compute the value for that variable, and is able to see that in the grid. Again, now let's add another column here, and this time what we do is use the new column that we had created in the previous step and use that to perform further calculations. Something like order total quantity. I mean, the exact formula here is not important. What I'm trying to show here is that the user just created an ad hoc field on the order class, and that ad hoc field is now available in this IntelliSense because it really got added within the code as a member variable of the, so again, the dynamic type, x.firstName did not exist. Here, order dot something did not exist. We created it on the fly, and we are able to use it in the code to allow the user to do ad hoc computations. This is almost like a macro language for the user to be able to do this. Similar to this, let's see if the user wanted to look at a chart. For example, moving averages are something that traders are very interested in. They look at moving averages of different times, and take critical decisions based on those moving averages. Every time, for example, a 5-minute and 10-minute moving average line will intersect, that that intersection point denotes a trade point for them, that the moving average is overlapping this point. They either buy or sell based on how they intersected and so on. So basically, what I'm trying to say is that the user wants to look at a graph of moving averages, for example, and he wants to look at, there's a stock graph which the application gives out of the box to the user, and then the user decides that I want to look at the moving average for 5 minutes, not the one that is being displayed. So he adds a new chart, time series chart within the existing graph. Now the important, again, one thing that I need you to look at here is the calculate moving averages function. So this function is like a domain specific language, library for you. So you could have within your organization, based on your domain, a whole library of such functions that users can then use at runtime to do ad hoc computation. So the function itself does not hard code how much time I need to calculate the moving average for. There are various other ways of doing it. You could have provided a field here, but what I'm trying to say is that this is a lot more powerful in the sense that this combines a domain-specific language along with a macro language, a scripting language that we've given to the user. The user can do whatever they want to do and create new formulas at runtime and use them here. They are able to basically plot two moving averages and look at them. Are both of them visible? Okay. Okay. Yeah, I mean, we can. Is done. So we have like two moving averages that the user created at runtime. So that's the power that I'm able to provide to the user over and above a rich UI-based application. So this is like a typical Silverlight application I could have created in WPF as well. It's a line of business application that you would create all the time, but the additional power of a macro language that I was able to add and provide to the user is something that the DLR allows me to do very easily. The next thing we'll look at is really how were we able to do this in this application. Sorry about that. Okay. So coming back to my presentation. There seems to be some kind of problem here. My machine is on. I'm trying to kill the browser, just like all demos. Something seems to be going wrong here. I am hoping that by closing the browser, I will not be kicked out of my webinar session. Don't do that. Okay. So the machine seems to have become responsive again finally. So we look at this. Now we are looking at how does this really work. So as I said, we were able to use Python to provide this this macro language kind of features within our application. So I want you to remember the 3-4 things that we looked at, where we created an engine, we created a scope, we used a string variable to create code. Then we converted that string, we compiled that string into executable code, and finally executed it. So those are basically the steps that we will look at here, how we have used those same steps here to provide the features that we just saw in the application. So first thing we do is set up this class called Python Engine. This has a oops, sorry. My machine seems to have a mood of its own, but anyway. So the Python engine has a string builder variable, member variable, and it basically initializes that variable. If you look at the bottom to a no-op Python function. So there's a def and update item, and within the def, there's just one line which says pass. So what that means is that this is a Python function which pass in Python is like do nothing. So I create the body of a Python function, and I am right now doing nothing in that function. Going forward, I will update this string builder to keep adding code within within the order object, as we were seeing there. So what you see here is, as I said, I have functions here within the Python engine which allow me to update that string variable, and so this is the kind of formula that user would have typed in, that order dot executed quantity is equal to order dot total quantity minus leaves quantity, which basically means that calculate this field and based on this formula. What I do is I update my definition of that function with this string. This string adds to the Python function which is being stored as a string builder there. Then when I call this update item method for the order variable, we basically update that the definition of the order object. Now it is important to know that the order object is a C# object. It is not a Python object. There we were seeing that we created a person object and we added first name on the fly to it, right, in the Python interpreter. There the person object was a Python object, a Python class. And versus here where order is not a Python class, it is a C# class. So how will I be able to add new member variables to a C# class? To do that, there are certain things that I need to do, and we look at here. So this is a simple way of doing that. What I do here is within the order object, I maintain a dictionary of key value pairs. And there are two functions that to which try get member and try assign value or whatever. These two functions are called by the Python code, by the Python DLR hosting code, when it tries to add, for example, when it tries to assign to a C# object, it will first call these functions, or after trying to assign, it will call another. So I basically get hooks into the life cycle, into the assignment cycle. Before assignment, then it will try to assign. If it is not able to assign, then it can also call another function which I can override here. So I get hooks into the hosting API, which allows me to add these values. So for example, order.executed quantity, which was not even a field within my order C# object, it got added within the dictionary as a key value pair, where the key is executed quantity and the value is the value which is computed at that time. And similarly, while getting, also it would go to that dictionary and get that value. Okay. So this is the Python hosting API, which is able to call these functions, and therefore I'm able to store these functions within the order object. Now I have stored these new values within the order object, but then how am I able to bind them to a grid, for example? Again, the Silverlight grid or the WPF grid is not aware of Python or of hosting APIs, right? How is that able to pull when I create, when I bind to a column, how is that able to pull out a member variable on the order class which is not even declared on that class? How is it able to do that? So that is the next thing that we look at. What we need to create is a value converter. The value converter comes to our rescue here. What we do is we within the value converter, we take the instance of the Python engine class that I showed you earlier. The value converter basically takes the name of the attribute, goes to the Python engine class, and says that, can you get me the value of this attribute from the order object? So all the dynamic values can only be written through the Python API and can only be fetched back for binding with the Silverlight column through the Python engine. So that is where the hosting infrastructure comes in here. So that essentially, and the rest of it is just is code you will be very familiar with if you've written any WPF or Silverlight programs where you have dynamic bindings. You create a binding object, you assign it to various values. That is how we were able to generate the new column within the grid. So that essentially wraps up all that I wanted to show you. Okay, this was not even visible. So I'll give you a minute more to read this because this was not visible while I was talking to it. Yeah, so that is the converter and that is the binding. So that wraps it up. To summarize, we looked at what a dynamic language is, what is a DLR, the features that a DLR provides, which is a dynamic type system, dynamic hosting, dynamic method dispatch, a hosting API, which allows C# and other static languages to basically interact with dynamic languages like Python. Then we looked at how these are used in like a console application or a hello world kind of an application. We looked at how, what are the typical features of a next generation rich UI application, which needs to deal with a large amount of real-time live data in which users have to do a lot of analysis and ad hoc computations. And then we finally looked at how the power of DLR can be harnessed to create like a macro language or a domain-specific language within such a UI based application to allow the user to do all their ad hoc computations right there within the application. So now I will open the forum for questions. I'll be happy to answer anything. You can read out the questions. How do I? So the question says, how do I get Python engine? I think this was so. So Python engine is provided by the hosting API. When I include the IronPython library within our, so the question here is, how do I get Python engine? Just because I believe users are not able to see the questions that I'm seeing here. The question is, how do I get a reference to a Python engine? So I add reference to IronPython within my project, and then I add a reference to Microsoft.scripting. So from ironpython.hosting.python engine, I just call create engine. That gives me a reference to the Python engine. I hope that was the question. What's next? Okay. Do we have a moderator here? Are there any questions? We're still waiting for questions. If you have any questions, you can go ahead and type them in here. I'll give it 2 more minutes. If you don't have any more questions, we'll wrap it up here. Okay, I think we're good here. There don't need to be any more questions. So thanks a lot for attending this. Hope you found this useful. Feel free to write to the TechGig people on the web page. You can continue to write your comments or ask me any further questions that you have, and I'll try to answer them as soon as I can. Thanks. Thanks a lot. म्यूट कर सकते हो Okay. Okay. I hope you can hear me now. So the question is there any way of
Yes, actually there are few more
finding out
questions.
if
There's few more questions I'm sharing with you. Can you please take them?
Yeah, I'm answering those questions. So I thought there were no more questions that were coming up, so I was about to hang up, but there are some more questions that are trickling in. So the question here is, can we do binding without really using a converter? Can we bind to the grid without using a converter? We can. This is the way I could think of right now. I'll be happy to review any other way that allows me to, one potential way could be that I create some kind of a dictionary within my view model or within my order object, which is keyed by the new variable name. There could be some way potentially. This is one way that I could think of. You could create that dictionary and then populate that with the values from the Python engine, and then bind to that dictionary instead of directly binding to the attribute that we had just created. Again, I'm just thinking off the top of my head. What is the main aim of DLR? So the main aim of DLR is to provide a CLR compliant version of a dynamic language, so to say. So what you get is, on top of the CLR, you get certain other services that allow you to write code managed code within a dynamic language. That essentially is what you get with DLR. Again, I mean, this is more like a philosophical question. There are different people who come up with different definitions, but that is one definition that you can take to begin with. Sure, I can find out from the TechGig people if I can host this this application on their website. Otherwise, if you Google around for integration scenarios where DLR is being integrated with Silverlight or WPF, you will find a lot of samples out there. But I will find out if this application can also be hosted within TechGig along with this presentation. How to integrate DLR in WPF? We just saw that. So the way we did here with Silverlight is how you would do that with WPF. I'm sure the set of libraries that you would need to use, the hosting APIs would be different for WPF, but that is exactly how you will use it there as well. The way we did here. Ruby, and so the question is any other language injection possible? You can do what we just did with Python. You can also do with IronRuby, which is a DLR equivalent of the Ruby language. Those are the two I'm aware of. There may be others out there that I have not looked at. Okay, so there's one more question coming in.
Any other language injection possible other than IronRuby and IronPython?
The same question being asked again, is there any other language injection possible other than IronRuby and IronPython? There may be, but I am not aware of it. There may be engines, so it is a question of whether a hosting API and an engine has been written for it. I'm not aware if there are, but you could just look for it on the web.
Okay, I think most of the questions are answered now. I will request all the audience to post their questions if they have any on techgig.com, and we will answer those questions offline.
Yeah, I will be happy to answer them when they're posted on the webinar page.
Okay, so we can conclude the session now.
All right. Thanks a lot for attending this. Thanks a lot. Bye.
Webinar. Admin session. And the recording of this webinar would be made available on techgig.com by tomorrow. I would also like to thank all the participants who attended this webinar. Thank you all.